You're having one on apes.
All right, so we're going to go over the homework here from 4-4. And I want to hear Luke's quote one more time. Dare I say?
Dare I say?
Oh, this was easy.
That's good. All right, so y equals ln of 2 times the log, I'm assuming that's base 2,
Yes.
of x. You have two options here. You can either change the base on this, which is what I am tempted to do, because I don't like taking the derivative of log base anything but e. So I'm going to do it that way because that's what I would tend to do. I would say ln of 2 is times, what is this? This is going to be ln of x times, or over ln of 2, right? And then what happens? And then I get y equals the natural log of x, and then I can take the derivative of that, which is 1 over x. Now, if you wanted to do it the other way, using the rules for log base something other than e, you could say that dy dx here is equal to, because the natural log of 2 is just a constant, right, times the derivative of this, which is going to be 1 over the argument, which is what, x, times the natural log of its base, times the derivative of the inside, which is 1. And then what happens here? The natural logs of 2 cancel, and we get dy dx equals 1 over x. So it's up to you. Maybe you're going to start falling in love with the change of base formula. I don't know. You okay with that?
Yeah, I was, not doing good things.
All right, question number 2, which was number 29. At what point of the graph of y equals, whoops, house I have ink, 3 to the x plus 1, is the tangent line parallel to the line y, is that equals 5x minus 1? What are they telling us in a top secret way here?
The slope.
The slope, what is the slope? 5, right? So the slope here is equal to 5. Is there another way to find the slope? Derivative. So dy dx here is equal to, this is a to the f of x, which is the natural log of its base times a to the f of x times the derivative of the exponent, which happens to be 1. And so I'm going to set that equal to 5. And so I'm going to say this is 3 to the x equals 5 divided by the natural log of 3. Now how do I solve for x?
Exponentiate.
No, it's already an exponential form.
Take the natural log.
Take the natural log of both sides. So this is going to be the natural log of this, natural log of this. So what happens to the x when I do that? Comes down in front, right? And we get x, natural log of 3, equals the natural log of 5 over natural log of 3. And then I say x equals the natural log of 5 over the natural log of 3, all over natural log of 3. So they want the point, right? Well, that's the x. How do I figure out what the y is? Is that what we didn't like? Or perhaps we don't like the way that looks?
Yeah.
Yeah. Well, that's just a number, right? And if we had our calculator, could we type in, let's go home to our calculator. I love that our 89s have a home key.
I love that we get to go home.
We get to go home. It's a nice feeling, right? So we're going to go home, and we're going to go 3 to the x plus 1, such that, what do we want x to be?
That.
So we say x equals the natural log, the parentheses open, and you're going to go 5 natural log of 3, close that parentheses, right? Close that log, divided by natural log of 3. The silence says view here is that they are quickly tapping on their calculator keys in silence.
5.551.
What is it?
5.551.
I need 551. I need 3 decimal places yet. So the point's going to be, do you think we can get a value for this? What?
Oh, just like that right there.
Yeah, I mean,
1.379.
I don't know what the book says, but are we in agreement?
I can't get that answer, the 551. I'm not sure. Showing probably nothing.
All right, so we're going to talk today about this process called logarithmic differentiation.
Oh my.
And in your packet here that I handed out, right, for before the end of class, you guys would, are going to take the derivative of this.
Really?
Let's just do it right now.
Because, you look at this and you go,
No thanks.
no way, because that's why I titled it that, right? Because I know you guys way too well.
That sounds
Nice 2-foot problems test.
No,
This is so exciting.
this is typically an 8-point problem.
I told somebody in advanced recall, I was like, oh, I skip back what problems all the time.
Okay?
What?
So,
She doesn't answer.
no, I'm live. So logarithmic differentiation is going to help us solve this. And right now, the way we would know how to do this is that we would rewrite this into exponential form, right, to the 1/2. And then we'd go power down, function, lower the power 1, times the derivative within the inside, which is a quotient rule, right? With ho being a product and high being a product. So that would be unbelievably
Miserable.
nightmarish.
I thought you were saying that's how we were going to have to do it.
No, we're not going to do it that way. However, we're going to use this technique called logarithmic differentiation, and all it means is you take the log first before you differentiate. Okay, so logarithmic differentiation means you take the log first before you differentiate. Okay, and I'm going to show you an example. We're going to do the very first one. Okay. Now, this we could do with the product rule. Be a little bit messy because you have power combined with chain for each derivative. But let's use logarithmic differentiation and take the log of both sides first. So this is going to be ln of this and ln of this. So that means we're going to have ln y equals the natural log of 2x plus 1 to the 5th times x to the 4th minus 3 raised to the 6th. Now logs are really cool things because they have some properties that can help us out. Can we expand this or unbundle it? Yes?
Can you do ln first plus?
Because this is the natural log of a product, we can say that this is the natural log of 2x plus 1 to the 5th plus the natural log of x to the 4th minus 3 to the 6th. Everybody agree with that?
Yep.
Now what? Can you unbundle this even more?
But 5 is
We can take this 5 and bring it down in front, and we can take this 6 and bring it down in front. And then we have the natural log of y equals 5 times 2x, 5 times the natural log of 2x plus 1 plus 6 times the natural log of x to the 4th minus 3. And now the right is totally expanded, right? I can't do anything else. Because these are plus signs, right? It's not multiplication, so I can't expand anymore. So now we're going to take the derivative how? Because I've had an explicitly defined function and now it's implicitly defined. So we're going to take the derivative implicitly. All right, so that means on the left-hand side here, the derivative of ln of y, recalling, right, the derivative of ln of f of x is equal to, if y equals ln of f of x, y dx is equal to
oh, that's
f prime of x over f of x, right? Okay, so what is f of x here in our case? So it's going to be 1 over y times dy dx, because when we take the derivative of y implicitly, we have to use the chain rule. Because it's 1 over the function times the derivative of the inside. I could also write this as 1 over f of x times, right, f prime of x. I mean, that's equivalent. And dy dx, I didn't figure you'd want a double-decker fraction. Is that all right with that? Are you all right with that? Okay. Equals. Now, 5 is just a constant. It's going to go along for the ride. And now I have another log function whose derivative is going to be f prime of x over f of x. What is f prime of x? 2 over 2x plus 1. There's nothing more easy than that, is there really? Besides the power rule. Plus 6 times 4x cubed over x to the 4th minus 3. F prime of x over, right? But I'm solving for dy dx, right? I want this all by itself, but there's something standing with it.
Multiply by y.
I'm going to multiply both sides by y, so I get dy dx equals, and I'm going to say this is 10 on top over 2x plus 1 plus 24x cubed over x to the 4th minus 3 times y. But what is y?
Oh, it's 2x.
It's this thing up here, right?
Thank goodness, why does
So
this
10
do it
over
zero?
2x plus 1
Hopefully this can get a little bit more challenging.
plus 24x cubed over x to the 4th minus 3 times, well, y was it 2x plus 1 to the 5th?
Yes.
Times x to the 4th minus 3 raised to the 6th. Now, it looks a little bit scary, but if I gave you the x value, could you find me the slope?
Sure.
And you don't have to find a common denominator in here.
Yeah, that would be horrible.
Well, but
I would seriously probably cry.
No, you
I would
wouldn't
just
cry.
go,
All right, moving right along.
That's
what
it?
would you do if you
That's
said
it.
Wait.
That looks awful.
That was semi-sarcastic.
This
It's
looks
It's a pretty long answer.
Like, yeah, if you
got
it
wrong,
you wouldn't know. You'd be like, look, that looks
Equals.
disgusting.
I'm going to write this in exponential form. So this is going to be x to the
1/2.
1/2 times e to the x squared times x squared plus 1 or 1 raised to the 10th. You have that already up there. Now, you would have to use the product rule, right? functions, which is not necessarily the most comfortable thing in the world, or we could use logarithmic differentiation and use logs to help us simplify it. So I'm going to take the log of both sides, and I get the natural log of y equals, now can we unbundle this all in one step? This is all multiplication, right? So it's going to be addition. And then what happens to the exponents on all of these? They come down in front. So can you go with me here? And this is 1/2 the natural log of x plus, what's the next one?
X squared.
X squared natural log of e plus 10 natural log of x squared plus 1.
Do we have to leave the natural log of e?
No, I'm going to talk about that in just a minute. So that looks like it'll be a whole lot easier to take the derivative of because there is no triple product rule involved, right? There's no f g times h. And as Skylar just said, what happens here? This is 1.
It's wonderful.
Wonderful, yep. And now we're going to take the derivative how?
Implicitly.
Because we took the log, and now we're going to take the derivative implicitly, thus logarithmic differentiation. So what's the derivative of the left side? 1 over y dy dx equals 1/2 times what's the derivative of ln of x? 1 over x plus the derivative of x squared, 2x plus 10 times, well, what's the derivative of the log of x squared plus 1? 2x over x squared plus 1. Very nice. Simplifying a bit, 1 over y dy dx is equal to 1 over 2x plus 2x plus 20x over x squared plus 1. And then I've got to get dy dx all by itself. So I multiply both sides by y. So dy dx equals 1 over 2x plus 2x plus 20x over x squared plus 1.
Good thing we know what y equals.
We know what y is, but I'm gonna put y right there just so. You getting it, huh? You like this?
Oh, not really. I mean, no comment yet.
Okay, fair enough. The jury is still out.
We started off this class being like, that was so easy, and we're like, never mind.
Okay, now, so y is,
Jinxed it.
didn't we say it was the square root of x times e to the x squared times x squared plus 1 to the 10th,
I
right?
believe we did.
And if I gave you what x was, could you find the slope? The answer is
No,
Sure.
I would
Yes.
cry.
I would more
If
than
you
love
wanted to count you,
no, it would be all right. Okay?
do it on the test. I'll just
You just
Flat
plug in
line.
eggs. Yeah.
Now,
see it.
this is a quotient
I got you. It is.
Surprise.
with trig functions, so how are we going to rewrite this?
I didn't even believe this.
Sine of x squared tangent of x to the 4th, because whenever you have trig functions raised to a power and you're going to take their derivative, you should raise them with parentheses because that's going to help you with the math. And now we've introduced a denominator. So what happens when you have logs and you have a denominator? It's now subtract, yes. So let's take the natural log of both sides, and we say the natural log of y equals. Can we do this in one step?
Sure, but you just mean like this.
Okay, so it's going to be this plus this minus this because it's in the basement, right? Because it's in the denominator.
Oh. So
It's as simple as that. If it's in the denominator, it's going to have a minus in front of it.
If there was like another, like if there was like in the numerator, how there's a product in the numerator.
If there's a product in the denominator, they both be negative
Okay.
because they're in the denominator.
Okay. So is it,
Does it, okay, and when you're in the denominator, what kind of exponent do you have if you're up here? Negative, right? So denominators always have negative exponents when you expand them. Okay? Alright, so this will be what? 2 natural log of sine x plus 4 natural log of tangent of x minus 2 natural log of x squared plus 1. And now we can take the derivative implicitly. What's the derivative of the left side?
dy dx
1 over y
times 1 over 1.
dy dx equals 2 times, well, what's the derivative of this log function here? It's going to be cosine x over sine x. Good.
This is so fun.
Plus 4 times, what's the derivative of tangent?
Secant squared.
Secant squared x over
Tan
tan x minus 2 times the derivative of x squared plus 1, 2x over x squared plus 1. And then we just simplify and multiply by y because we're solving for dy dx here. So I'm going to do that in one step here. So this is going to be, what is cosine x over sine x? Cotangent. So this is 2 cotangent of x. And I think I'd leave this. 4 secant squared x over tan x minus 4x over x squared plus 1 times y.
Good thing to know.
But what is y?
A really nice number. Sine squared x.
Sine squared x,
Tan to the fourth
tan to the 4th x over
x squared plus 1 y squared.
squared. There we go. There's dy dx.
Okay, I'm not gonna have
Not
room
to be
to do one
really
next to it.
Shape
At
or
what
anything.
point do we take 4 secant squared x over tangent x and try to simplify that?
I wouldn't. I never.
Don't even think about it.
Because, well, you could do 1 over tangent x is cotangent, right? I mean, so you could go cotangent secant squared x. Yep.
This is like back on number 2, but why would the derivative of the natural log of x be 1 over x? Again, like I said.
Why?
Yeah, I don't know, maybe I've not seen it, but like, that's confusing. Might just not.
How do we take the derivative of this? Well, we're going to exponentiate. Okay, and we get e to the y equals, this goes away and we get x,
Okay.
right? And then we're going to take the derivative explicitly, or implicitly, which is e to the y dy dx equals 1.
Okay.
Dy dx equals 1 over e to the y. But what is e to the y?
1 over, I got you. Thank you.
Wait, how did you go from the second step to the first step?
From the second, this step,
No. Upward. Yep.
I took the derivative of e to the f of x, which is e to the f of x times the derivative of the
Oh,
exponent.
got it.
Okay.
Wait. What have you? 1 over y times.
No, that's, I didn't take the derivative of log of y.
Oh.
Okay, so,
Could you
but
just
I,
do the f prime of x over f of x?
yeah, what, you want to do that one too?
No, could you just, like, for the ln of x, could you just do
Yes, you can. Yes, you can, but he asked why ln x's derivative is 1 over x. Now, Robert, that's something I'd memorize. I wouldn't go
Yeah.
through this derivation every time.
Okay.
Do you know what I mean? If you
Yeah.
see this, you need to think dy dx instantly is this. That needs to, right, just like that.
Okay.
All right, what about this one?
raise it to the.
Right, we're on the top and the bottom?
Oh, yeah.
I think that'd be easier, don't you?
I don't know what you're talking about.
Oh,
Well, because if you do if you raise it to the 1/4, the 1/4 is going to be 1/4 times brackets the log of, because it has to belong to the top and the bottom, right? So I think in this case, to make things simpler, I would write this. Right? I mean, that's equivalent. Do you agree?
Yes.
And I think it's going to be easier to unbundle or expand. So let's take the log of both sides. We get natural log of y equals 1/4 natural log of x squared plus 1 minus, good, 1/4 the natural log of x squared minus 1. Now we're going to take the derivative.
yes.
Implicitly, which means we're going to get 1 over y dy dx is equal to 1/4 times the derivative of the inside, or of the log, 2x over x squared plus 1 minus 1/4 times 2x over x squared minus 1. And then we're going to solve for dy dx, which requires us to multiply both sides by y. So I can reduce, right, this 4 and this 2, and this will be a 2 here, and then this 4 and this 2, and this becomes a 2 down here in the denominator. We get x over 2 times x squared plus 1 minus x over 2 times x squared minus 1 times y, which was 4th root of x squared plus 1 over x squared minus 1. And that is just y, right?
So it wouldn't matter if we multiply the 2 out in the denominator.
No.
Okay.
All right. Moving along.
What is?
This is an interesting function, yes? X to the 1 over x.
That's fine.
Alex seems really exciting.
Okay. You.
So,
first.
when you have y equals a function raised to a function, that meaning the base has a variable in it and the exponent has a variable in it, that's like a hybrid, isn't it? It's like not a power function, but it's also not an exponential, is it?
Correct.
Anybody got a mixture of a word that we can come up with a power exponential? How do we say that?
Okay, what does it start with? What does it start with? What does it start with?
Well, we got a power function mixed with an
What
exponential.
does it start with?
What? No, she's asking us to make up a word.
Power
I thought
exponential?
she was saying there was
Power
a
exponential?
No, that doesn't seem very fun. I think we should go with pain. I like it better.
Right.
Exponential.
All right. The only way to solve these or to find the derivative of these,
Wait, no, guys.
the only way, listen, I'm recording this. The only way to take the derivative of this is to take the natural log of both sides, because you have to get the exponent down low. Okay? So let's take the natural log of both sides. We get the natural log of y equals, what happens to the, I'll do it in 2 steps. This is
Bring it out
x
in
to
front.
the 1 over x. So that means I can bring the 1 over x down in front. Natural log of y equals 1 over x times the natural log of x. Now when you do this, it automatically sets up a product rule on the right.
Sweet.
That was Skylar for the record? Not me?
No.
Okay.
I was going
I know,
Oh.
I'm just saying.
I thought it was perfect.
Now we're going to take the derivative. equals, L first,
First, 1 over x.
D second,
Times 1
I want to show the
1
steps,
over x.
plus second,
Ln of x.
times the derivative of the first,
Negative 1 over x.
negative 1 over x squared.
Plus.
Nice. All right, so let's simplify. We get dy dx equals 1 over x squared, as Nathan said, all in one step.
Can you explain-
Minus, hold on a minute, natural log of x over x squared. Yes, sir?
From negative 1 over x.
This, I could rewrite this, right, as x to the minus 1, natural log of x.
Oh, yeah, you can.
Right, so then I'd bring power down, function low to power 1. So that's where we get this.
Okay.
Times 1.
Times y. But alas, what is y?
Not y.
1 over x squared minus natural log of x over x squared. And y was x to the 1 over x.
You're so ugly this color.
What?
You're just
Could you
really
do-
ugly.
Could you do 1 minus natural log of x over
I
x
think
squared?
beauty's in the eye of the beholder.
Yes, you could.
Thank you, Skylar. Do you find them beautiful?
Yes.
Alright.
Because
When we get to the test.
I think it's in the smaller
Do we
size.
have it?
Whatever.
Moving right along.
I'm sure they have really nice personalities, but they're a little.
I don't.
Tim, what are we going to do?
Tim.
So like, we think they're better than everyone else. Natural log
Scared
both
sides.
Whenever you see
Splitty.
Yeah.
You don't play trick question.
Natural log of both sides, which is the natural log of y equals
Equals
what?
sine x natural log of x.
Sine x, good, times the natural log of x, which requires what on the right? Product rule? All right, now we're going to take the derivative. Implicitly. So the derivative of the left-hand side is?
1 over y dy dx.
What? Yep. Plus, or the right side is first,
Sine x.
the second,
1 over x.
plus
Natural log of x.
natural log of x times, you know what? Cosine x.
Cosine.
dy dx equals sine x over x plus ln x times cosine x times y. But what is y?
X to the sine x.
X to the sine x.
So even though that's a identity for sin x over x is for limits, it doesn't help you at all here.
No.
Oh, I thought so.
Uh-uh.
Well, that was so stolen.
Sorry? What'd you say?
At least I recognize you. Yeah, good job.
Moving right along.
We're just moving. So,
All right, Maggie, you're helping me with this one.
so cold.
Skylar, you're next.
Okay, can't wait.
Okay.
What do we do?
Take the natural log of both sides, so yeah. Natural log of y equals x natural log of sine x,
Yep.
and then you take the derivative partially. So 1 over y dy dx equals. Oh, do you have to do the product? Okay, so equals x times cosine x over sine x
Mm-hmm.
plus or natural log of sine x times 1. So
Yep.
yeah. So you get x cotangent x
Yep, I like it. X cotangent x
plus natural log of sine x
all times.
sine x to the x.
And remembering, right, that this is y, and that's how you multiply both sides. Alright, Skylar.
Alright, we're gonna take the natural log of both sides?
Yep.
So we get natural log of y
Yep, equals.
equals x, natural log of the natural log of x.
Oops, yep. I don't know why I did double parentheses, we'll fix that. It's weird. Alright, now what?
Alright, then we're gonna go dy dx.
Yep, we're gonna take. Now there's a reason I write this every time. Because a lot of times people will do the log, natural log of both sides, do an excellent job of unbundling it, and then not take the derivative.
Just like leave it like that.
What?
Like they'll leave it like that.
Yeah.
That's so rude.
So, what's the derivative gonna be?
Oh man. dy dx.
Nope, 1 over.
Times 1 over y. Equals, first, x. The second, which is 1 over the natural log of x. Okay. And then
Times.
times ln of x.
Nope.
Times,
What's the derivative of the inside?
oh, 1 over x.
Yes. Plus
Plus second.
ln of x times the
Times
derivative of the first, which is. Now, can you see how we can simplify this here?
Yep.
Could you put the 1 over x on top?
Yeah.
Sure, but then it still cancels.
Okay.
So we get dy dx.
Equals 1 over ln of x plus natural log of the natural log of x
Times.
times y, which is actually that. And I need to write this down. Wait, so when you're doing the control, did you have to do it?
Times the
Yeah, I was
derivative of the
trying to
first,
figure out
which I
the
didn't
second
show here, which is 1.
Yeah, so it's first,
First, d second.
plus
Second. And if it helps you to write, this is the first, this is second.
Okay. But for the second one, in the first part, yeah, for first, D second, for the D second.
do the.
You go 1 over this times the derivative of the inside, which
Okay,
is
times
1 over x.
okay. Okay.
Wait,
I heard wait.
wait, yes, okay, sorry, I think you just explained this, but I couldn't see. So, for the derivative of ln of ln x, what do you do?
It's f prime of x over f of x, right? You've just been taking a bunch of derivatives of ln x.
So do you like never have to use the chain rule with this?
I did use the chain rule.
Okay, that's what I was confused. Okay.
Right? Because that's, I went 1 over this
Right.
times the derivative of that, which is
Wait, what?
1 over
I
x.
got it.
When you do the derivative of this, which we were doing, what's the derivative of that?
3x squared over x plus 1.
Okay, so you went 1 over this
Uh-huh.
times the derivative of that.
Right.
You did use the chain rule here, you just don't realize it.
What?
Okay? Who's gonna help me with this one?
Oh, I
All right, Jake, go.
To get the like that.
Take the natural log
Which just gives you
ln y
equals,
ln x times ln x.
alright?
And then take the
And what do we get?
1 over y times dy dx equals the natural log of x over x plus natural log of x over x, and then
there's two of these, right?
Yeah, so could you just put two tables?
Okay, so you didn't like the way he took the derivative? He went first. What's the second? Plus second.
D first.
D
Right,
first, which is
yeah,
one
okay,
over x.
got it.
Okay? Now, I do this one on purpose because there's another way we can write this. Do I have the same base here?
Yes.
What's the exponent to the x in the bottom? 1.
Oh.
Well, I mean, so I could rewrite this as 2 natural log of x times x ln x minus 1.
What? I don't even know what this is.
But do you have to?
Because this is to the first down here.
Do we have to do this? Or no?
Where are you going to see that?
Multiple
Yeah.
choice.
I don't.
Hold
Could you
on.
do that one? Yeah. Could you walk through that one? Like write it out.
So your derivative is 2 natural log of x over x times x ln x, right? Could I rewrite this as 2 ln x times x to the minus 1 times x to the ln x? Could I do that?
Okay.
Add the x.
And then I'm going to add the exponents on the x's.
So the same base.
So this is 2 natural log of x times x to the ln x minus 1. You see how I just moved that? When I move this up to the numerator, it becomes a negative exponent. Okay? Who's going to help me with this one? All right, go ahead, Tricia.
ln of y equals e to the x times ln x.
Good. Now we're going to
Take the derivative implicitly.
okay.
So 1 over y times dy dx
Yep.
equals first, so e to the x,
Mm-hmm.
d second 1 over x,
Yep.
plus second ln x, first e to the x.
Good. And then dy dx.
dy dx equals e to the x over x,
Mm-hmm.
plus e to the x times ln x times y, which is
X.
x times e to the x.
X
Isn't
to
it
the
easy to-
I know, I'm sorry. I have to break for it. There we go, right? Now, I mean, you could theoretically here factor out what? E to the x and say 1 over x plus natural log of x, e to the x, x, e to the x. I mean, I don't know if that'll help, but you might see that version somewhere. Questions on that? Yes.
How we get e to the x
We took the product rule here, we went first, times the derivative of the second, which is 1 over x, plus second, times the derivative of the first, which is e to the x.
Yeah, how's the derivative of the x?
Do we remember this up using the properties of exponentials. If you are adding your exponents, you can bust it up with multiplication. And so can I factor out an e to the x? This is the limit as h goes to 0 of e to the x times e to the h minus 1 over h. And last time we came up with this limit as one of the ones we should know. And what does it equal, everybody? 1. This equals 1. And so the derivative of e to the x is just itself.
Okay.
All right, Julia's going to do this one, and then Luke's doing the last one.
Luke, I mean, if you wanted to, okay.
Which one do you want to do, Luke?
I'll do this one.
Okay, here we go. What are we going to do?
Take the natural log of each side.
Natural log of y equals?
Cosine x, natural log of x.
Okay.
And then take the derivative implicitly.
Wait, isn't it
Wouldn't it
cosine
be-
x natural
Luke, you're
log
wrong,
of
aren't you?
Oh, I'm
Oh
sorry.
yeah, cosine.
I followed him.
Oh,
Sorry.
you're bringing this down.
I'm sorry. You're right. And what do we get?
1 over y times 2y dx equals. Would this be a product?
Yes. Every time you do this, it's a product on the right.
Alright, so it'd be cosine x. And this way gets tricky. Oh, okay, so it'd be 1 over x. No, 1 over natural log of x
Times
times,
the derivative of this.
which is x. No.
The derivative of ln x.
Oh, 1 over x.
Yes. Plus
Why is it 1 on the top?
what?
Why is it 1 over natural log?
Well, we're taking the derivative of ln of x, right? So it's going to be 1 over the inside, whatever it is.
Yeah, oh, because it's not, there's no,
Right.
okay.
Plus
Natural log of x
natural log of the natural log of x times.
times negative sine x.
That's very nice. dy dx equals
Cosine x over x natural log of x
minus
minus natural log, or well, do you want to put the sign first?
Yeah, I did. Sorry.
Sine x natural log of the natural log of x
Times
y, which is natural log of x cosine x.
Can you go back or something?
I should have reported the last lesson for 8. I should have recorded the last lesson for you.
She's like, yeah.
Yeah, for sure.
I know. Last week it was kind of a blur for me because of all the letters of recommendation I had to write. Right. So I was a zombie.
Oh, we
You
appreciate
guys
your hard
did a
work.
lot.
You're gonna get us into college.
You know,
Yeah,
you guys
thank
can
you,
get
Miss
yourself into college. I'm just
Helping like a lot.
helping a little bit. Yeah. All right, who's gonna do this one?
Yes.
All right, here we
Okay,
go. What
so
is it gonna do?
You take the natural log of both sides, so you get Linny equals 3x times the natural log of 2x, and then you take the derivative implicitly. So then you get 1 over y times 2y dx So then you get 3x times 2 over 2x
Yeah.
plus the natural log of 2x times 3.
Yep.
And then you get dy dx equals 6x over 6x squared. So
Well, I can cancel these 2's, right?
yes. So
And I can cancel the x's.
oh, I did.
Just 3, right?
Yeah.
3 plus
3 times natural log of 2x
times.
times y, which is 2x to the 3x.
Very good.
I don't know what I tried to do.
So that's it. We worked the entire packet, didn't
That
we?
one I could have.
Oh, no.
This isn't actually too up.
I really haven't done the very first problem.
These ones.
All right. So why are we doing this? Well, because we need to find these curves have slopes that have to be found. And tangent lines, right?
Oh my gosh, that means we're gonna have to use
All right.
that really ugly number and put it as
So here we go. I'm going to go to Desmos, and we're going to graph this. What is it? Y equals, no, it means 2x plus 1 to the,
X plus 1.
Maybe I have to do it.
yeah, you're probably right. Okay.
Good job, Patricia.
All right, and then what's my point going to be?
1, 9.
1, comma, 9. So does it look like it could have a tangent line there?
No, so, turn back.
Like other people.
All right, so how are we going to do this?
Take
We're
the
gonna-
derivative.
We're going to take the derivative because we have the point. All we need is the slope. So who's going to help me with the derivative?
I go,
All right, go, Griffin.
well, you take the natural log of both sides
So we get ln of y equals,
equals x plus 1
uh-huh,
times the natural log of 2x plus 1.
all right, good.
Then you take the derivative implicitly.
Yes,
So then you get 1 over y times dy dx
equals,
equals first, so x plus 1
good,
d second, which is 2 over 2x plus 1
good, plus,
plus natural log of 2x plus 1 times 1.
yes, very nice. But we're not done yet, right?
Nope. We get dy dx equals 2x plus 2
Yep.
over 2x plus 1.
Now in this case, and then we're going to multiply by y, right?
A nice number for your slope.
Right, Griffin? But do we know what y is? Did they give us a y?
Yes.
So we can leave the y here because we know that we can find the derivative, I mean the slope, right? I can go such that x equals 1 and y equals 9. So what does that slope equal? This is going to be 4 on top, right? Over 3 plus, so this is going to be 4 over 3 plus the natural log of 3 times 9. That's a slope. It's ugly, but it's a slope. Well, maybe it's not ugly. Maybe it's a little
Multiply
ugly.
it out.
What?
It's like
Just
the
triple
other.
divide.
No, I'm going to leave it because all I'm going to do is write the tangent line right now. How do I do that?
You do
I'm not going to let that number intimidate me or you. At 1, 9, what's it going to be?
y
Y
minus 9
minus 9 equals,
equals parentheses 4 over 3 plus natural log of 3
and we're gonna prove it. Right, because we're gonna go to our Desmos and type in our equation, right, which is gonna be
Y minus 9.
y minus 9 equals, I'm gonna put the 9 in front, is that okay?
Yep.
Times 4 divided by 3 plus natural log of 3, close parentheses, times
X minus 1.
x minus 1. Did it work?
Yes.
Yeah.
That is tangent. I would say that is tangent. You okay?
Next one.
Oh wait, we have to find a normal line.
So the normal, what are we gonna do?
Negative 1
Negative 1 over that,
Yeah.
yes, okay? And you, I would leave the that, I'd leave it like negative 1 over 9 times, right? With parentheses, I wouldn't simplify that, I just leave it. Leave it over here.
So, norm.
That was a mega delay, right? The normal line at 1, 9 is going to be y minus 9 equals negative 1 over 9 times 4 over 3 plus the natural log of 3 times x minus 1, right? I just leave it like that.
That was a lot.
Hmm?
That was a little ugly, but that one's a lot ugly.
Alright, Liz, you got this one.
You would,
I don't do that.
you have to put every 1/2 top and bottom.
Yep. I just think it'll make your life easier. Your logarithmically differentiating life easier. God bless you. So what are we going to do?
Take the natural log of both sides.
Natural log of y equals?
Then it would be 1/2 ln of x
Good.
plus 1/2 ln of x plus 2 minus 1/2 2x plus 1 and then minus 2x 1/2 natural log of 2x plus 2.
Yep.
We just pause for a minute.
Yep.
I shifted over.
And then we're going to take the derivative implicitly.
Wait, why would
Would
we
you put the
s-
whole numerator in parentheses?
Sorry?
Would you put the whole numerator in parentheses or no? Or is that a question?
I don't know what
Because
you
if
mean.
it's a fraction? Or do you keep everything separate?
I would just raise everything to the 1/2, right? Because with exponents, you can give you can distribute the exponent to all of those.
Wait, but you're subtracting
Because it's in the denominator?
Yeah, so would you not keep the numerator in parentheses?
put minus.
She just
subtracted both okay.
pieces. Oh, okay, sorry.
You know what? When I teach logs, when we're expanding, I would just, if it's in the bottom, it's negative.
Oh, yeah, that's
Right? What's in the denominator, it's negative. All right. 1 over y dy dx, right, Patricia?
Yes, equals 1/2 times 1 over x
Yep, so it's 1 over 2x, good.
plus 1/2 times 1 over x plus 2
Yep, and the derivative of the inside is just 1, so that's perfect.
minus 1/2 times 2 over 2x plus 1.
And we can reduce the 2's, right?
Yes.
the x's, did they give us the y here?
Yes.
So we don't have to, put the y on the other side. We can just, put the letter y instead of what it represents. Plus 1 over 2x plus 2 minus 1 over 2x plus 1 minus 1 over 2x plus 2 times y such that
X equals 1,
and y equals
1/2.
1/2. So let's simplify that. What do we get? We get 1/2 plus
1/2 plus 3,
1/4,
1/4.
right? 1/4 minus,
Minus 1/3.
yep,
Isn't that 1/6, not 1/4?
where?
Because if you have a 1 plus 2 is 3 times 2.
Oh, yes.
Oh, yeah. Yes. I should do my PEMDAS appropriately. Yes, 1/2 plus 1/6 minus 1/3.
And then it would be minus 1/4.
All that times.
All that times 1/2.
All right, my common denominator looks like 12. Yes?
Yes.
So that's 6 over 12 plus 2 over 12 minus 4 over 12
minus 3 over 12.
3 over 12, all times 1/2. So it's going to be 8/12 minus 7/12, right? Which is 1/12 times 1/2. That's a little tiny slope.
Wait, why are you multiplying by 1/2?
Because that's what y is. Because we have to bring the y, right?
Right, okay, yeah.
So, okay, so that's the slope. So the tangent line,
Tangent line is y minus 1/2 equals 1 over 24 x minus 1.
good. And the normal,
Would be y minus 1/2 equals negative 24 x minus 1.
all right. So, the back. I would put it at an angle or, sideways, and you guys are going to take the derivative of the front.
Can you put
Can you put it up on the board?
Yes, I can.
Wait, is it solvable?